Hello developers, let's start developing. Today we're gonna take on the 13th task of the 2022 Advent of Code, and this means that we're gonna get to the middle of our Advent of Code adventure. We have 12 tasks done and 12 tasks more to go. So I've taken a look at the whatever of that the task. So now we need to do some kind of analysis of some singles of the signals, and we need to determine if they are in the right order or not. Basically, we need to determine if the one above is big less than the one below, so to say. But these are nested signals, so we have these cases. If we are comparing this, we are comparing one with one with one, three with five. The left side is smaller, so it's okay. If the right side is bigger, then it's not okay. If they are equal, we are continuing with the next item. And we have some other issues. If the left side runs out of item first, it's okay. If the right side runs of items first, it's not okay. Yeah. So those are the tasks, and this is the input. So we have two lines and then an empty string, and two lines, then an empty string. So in order to parse this input, I've created this signal class. So a signal will be two sets of arrays where I will have the data. And the data, I termed it as a deep array. Because what is a deep array? The problem is this here, that we will have arrays that are kinda arbitrarily nested. Because this is a simple array of numbers. But this is an array of numbers. And this is something else. This is an array where the first element is an array of numbers, and then we have numbers. And then we have this, which has a number, then an array of a number, and an array of a number, and an array of a number, and so on and so forth. At the very end, we will have an array of numbers or a number. So that means that our deep array can have three different things happen with it. It can either be a number, or it can be an array of numbers, or it can be a deep array, an array of deep arrays. And we should be able to basically have this model all of our cases. So we need to process our input, but not like this. And this time we got quite a bit lucky because we don't really need to parse the input. Let's see what happens. I can say where lines.map, not listeners, lines. Come on, lines. Oh, it's not lines, it's called input. Dot map, and we can map each line to the line is a string, and we can say JSON.parse the line. And this will give us some kind of an object. Let's see what those objects are. And thou shall not do this, but in this case I will totally abuse it. This maps each of our item to an undefined value, but as a side effect, return an empty array. As a side effect, it will also log the values to the console. Unexpected end of JSON input. Oh, we tried to convert an empty string to JSON, that's not gonna work. So we can just say filter line. It will just return the truthy values. And here we have it. Because the format in which we are given the data is actually totally identical. Yeah, I'm doing some error here in the mapping, but doesn't really matter because the format in which I'm using, it looks all the parameters to the map. The way that the input is given is basically already in the JavaScript format. I feel sorry for people with other languages that will have to actually parse this one by one. There is a lot of brackets to map, but we don't really care because here is one line, here is another. You can see those are already ready-made. Here is yet another. And the complicated one from below it's here. Somewhere along the line, the console log just gave up and said, well, this is an array. I'm not going to go in depth, but I have almost no doubts that it's going to be the correct one. Still, now we will need to do some kind of a mapping because we don't want only the data. We need to group them into signals. I will rename this to lines. So we can say while lines dot length is bigger than 0, it's not gonna be this, but it's gonna be something similar. That is a signal array, it's an empty array. We're gonna say line or left actually is line dot shift, right is line dot shift, and we're gonna shift once more, and then we're gonna return, not return, but result dot push, not left and right because those are strings, but we're gonna JSON dot parse left and JSON dot parse right. Let's just have it like this. Oh, and let's avoid the mistake that we did last time, that we had to debug to see what the problem was. We're just gonna return the result. And here we have it. We have the left and we have the right. And now we just need to run a compare function. And we just need to say, I don't see a place in the input when the inputs are totally the same. And if they're not totally the same, that means that we can get some kind of value. So either the first one is bigger or the second one is bigger, and that kind of holds for this as well. If it doesn't, we're gonna explode and see what happens. So we can just say that this compare signals would return true or false. It can return a boolean. So it's not a compare, we can call it is in right or there. And what happens here? We have a left a deep array, and on the right we have a deep array. So it supposes this. So we have basically three options, and two of them are arrays. And if the third one, it's not if it's if we have we need to compare two numbers. Yeah, this is wrong, but let's just take care of the situation when we have both values are integer. The lower integer should come first. If the left integer is lower than the right integer, they're in the right order. If the right is higher than are not in the right orders. Otherwise, the inputs are the same integer. Let's have this return a numeric value, so to say. 1, 0, minus 1. We have that. Oh, we need to specify it here. So this will return a 1 or a 0 or a minus 1. Let's ignore this part here. Or we can have it return a number. And just like the sort method. The sort method basically returns a number, and if the number is positive, then the first one is bigger. If the number is 0, they are equal. If the number is negative, then they are the one is not bigger. So we can just return the right one minus to the left one. If both are integers. If exactly one value is an integer, we need to convert it to a value. So, yeah, we will have that. This. Yeah, let's have it like this. Left is array, right is not. Left is bigger. This is wrong, but something like this. And here we actually deduce that the right is a number and the left is a number. So, if the left is an array and the right is not, then we need to simply return is in right order, not this. The left is still an array, but the right is this. It's an array of the only element. If the right is an array and the left is not, we will need to do the other thing around. So the left is an array now and the right is not. And if both are integers, just return right minus left. If this returns negative, that means that we're good. If this returns 0, we will continue on. And if this returns positive, then we are broken. No, the right should be bigger than the left. So positive is good, negative is bad. So we just need to implement this case. If both values are list, compare the first value, then the second value. So yeah, we can go at it this way. Something like this. We are running on the left. And if the right list return runs out of item first, the inputs are not in the right order. So we are looping through the left list, which means if we get to an index that is equal to the length of the right, we have this case, the inputs are not in the right order, which means right order is negative. Not in the right order is negative, -1. Otherwise, we still haven't run out of items. The right didn't run out of items. If the left list runs out of items first. So if we get to this point, we know that we passed through the whole left list, and we didn't run out of the right list. So that means that the right list has more elements. This is the case when the left list will be 1, 2, 3, and the right list will be 1, 2, 3, 4. So we passed through whole of the left list. We compared everything with the right. Everything is okay, but the right list still has more elements. That means that the left list ran out of items first. The inputs are in the right order. So we are going to return 1. Otherwise, while we are doing that, check this, and if the result is not 0, then return the result. If the result is 0, then return 0. No, if the result is 0, continue with the next element. And also, if both are arrays and we pass through everything and we have everything running totally and they are just exactly the same, the exact same length, the exact same data, then just return 0. So now, instead of console logging signal, let's say signal left, signal right, and we're gonna just console log. We have, if the result is less than 0, then we have not right order. Otherwise, we have right order. And just for the sake of, I like for of loops much more than I like for loops, so I will actually do this. And we also have one based index because we're gonna need the index for the result, and the first index is 1. So we're just gonna console log this as well. Avoid the plus there. Never do this. Never ever do this. This is an awful suggestion. Console log should not change your data. If console log changes your data, that means that I commented out the console log, which people do constantly, and change the behavior of my system. Never do that. Never ever change data inside a console log. But I do want this index to increase, so I will put this here, and I already explained I like this one best. Why? Because I do. So we already have some data. Signal 1, right order. Let's compare it. Signal 1, right order. Signal 2, right order. Says okay. Signal 3, not right order. Signal 4, right order. Yep. Signal 5, not right order. Signal 6, right order. Yep. Signal 7, not right order. Signal 8, not right order. Seems kind of stable. So let's see what we actually need to do. The pairs in the right order are 1, 2, 4, and 6. The sum of those indices is 13. So we need to sum up the indices. Let result is 0 if they are in the right order. Result plus equals 1, not 1, index. Oh, we have two kind of results here. This is the comparison, and this is the result. Did I save it? Yep, I did. Oh, I saved it once it got started. It says the result part 1 is 13. Let's just beautify these console logs a bit. And now, if we want to, we can comment them out. Yeah. Commenting out console logs is a great strategy when you're developing, not so great strategy for production. But we are developing right now. So we have a lot of data. We need to restart it because the input itself is not watched and it says it's 6070 for the first part. Let's see if that is the correct number. And apparently it is, which means that our compare function is really doing the job. Now we need to put all of the packages in the right order. Disregard the blank lines. The distress signals also will include two additional divider packages, a 2 and a 6. Using the same rules as above, organize all packets, the one in your list of received packets, as well as the two divider packets into the correct order. Afterwards, look at your divider packages to find the decoder key for these distributed indices of the two divider packets and multiply them together. Are 10 and 14, and the decoder key is 140. Aha! Let's see. Yep. So this means that we need to run a sort across all the signals. Yeah, the input for the second part is just not the same as the input for the first part. And I will just move this method, which I made a very good decision that I used the -101. But right now I think I have a problem because this actually says 1 if they are in the right order. So if I try to order the inputs using this as a comparison, I think that will order them in the wrong way around. Anyway, let's try it. Let's just take the small input first. Yeah, only 20-ish things. So we need to say on this are packets is actually input dot flat map for each signal. Give me an array of the left and the right. And after this, I will have a flat array of all the signals. So this should be an array of deep arrays. Since the left and the right is that, and I'm gonna need to push two additional arrays, and that's the that one and 2 and a 6. An array, actually yeah, this array is an array with one element whose element is the number 2. So, and now I can just do packets.sort. Oh, push returns a number. So I will need to do packets dot push on a separate line. That one and this one. And actually I'm gonna do a trick. I'm gonna define this and hold on to the references. 2, 6. Store them in the right order and just console.log packets. Let's see what happens now. Yep, as I expected, they are sorted exactly in the way they shouldn't be. And again, I'm missing the 2 and the 6. No, I have the 6 and I have the 2. Yeah, everything is great. Only they are the other way around. But I think we can solve this by just flipping the way they are being compared. The other way to do it would be basically to negate the result. I could have said minus this and the 0 would stay the same. Minus negative values go to positive, positive go to negative. So we have, I guess, the thing we need. Let's see. And we need to find our 2 and a 6. And this will be a problem if in the input we have such a value already. Let's see if that happens to be the case. Do we have a 2 somewhere? No. Do we have a 6 somewhere? No. Because if we do, we might get the wrong index. Because there will be duplicates. This cannot distinguish between two identical values. So now we can just say console log packets dot the helpful method find index of. Actually, we have index of 2 and index of 6. We would have to use find index if we didn't got the references, but now we have references to the specific array that is the 2 array and a specific array that is the 6 array, and we can just return them. 9 and 13. And of course, they are not 9 and 13 because we are using normal JavaScript counting of arrays that starts at 0. They are the 10th and the 14th, and the decoder key is 140. So what we will need to do is we will need to say const to index to index. That's a nice name. It's index of 2 plus 1 and 6dex. Yeah, this is the good number. That's the index of 6 plus 1, and we just need to return twindex times 6dex. Let's see what we get. We should get 140. Of course we do. Now, let's just see if this happens for the huge array. Oh, of course, we need to restart it, and we see that the processing time is something like 7 milliseconds. Let's see if this is the decoder key for the distress signal, and it is. We've completed day 13. And I have to say this was very easy task once you get through all the intricacies. And we had terrible luck because we are using JavaScript and the parsing of the input were more than trivial. We just said, well, take the input and treat it as a JavaScript object, and that thing worked. We just read the rules nicely. The nice reading of the rules provided us with a nice is in right order method, and then we basically just used that one and got the result. Thank you for watching, and don't forget to like and subscribe, of course, and see you tomorrow.